检查是不是正常？好，没有事。
Hello, hello. This is the second homework for this course. The TA can help you during our office hour. The office hour are every Monday from 2 p.m. to 4 p.m. and every Thursday from 10 a.m. to 12 p.m. at CS9E, 9th floor robotics lab. Now let's talk about some important rules. First, copying is not allowed. If you copy someone else's homework, both of you will get score of 0. Second, the submission deadline is December 27th, Friday at 9 a.m. If you submit your homework up to 7 days later, your score will be reduced by half. And if you submit after this period, you will receive a score of 0. You must attend the demonstration, otherwise your score will be 0. The demonstration schedule will be announced on NCKU Moodle later. And you must create a graphic user interface, otherwise your point will be deducted. Finally, you must upload your file to this address and path. The address is for FTP and user ID shown here and the password. Make sure your file name is correctly. The format should be like this. HW2 underscore and your student ID, your name, and the version. If you want to upload your file, you should update your version, like version 2. The submission content should include the project file, excluding the pictures, and you need to remove your debug folder to reduce the file size. Here are the recommended Python packages and their corresponding version, but you don't have to use the exact version shown here. This homework has 2 parts, and each part is worth 50% of total score. Now I will introduce the first part. The first part is about training a Cipher10 classifier using VGG19 with batch normalization. The 10% score is for loading Cipher10 and show 9 augmented images with labels. And 10% is for load model and show model structure. Another 50% score is for showing training and validation accuracy and loss. The final 15 points is for using the model with highest validation accuracy to run inference, and you need to show the predicted distribution and classes label. The objective of this part is learn how to train a VGG19 with batch normalization model to classify 10 different classes images of Cypher 10 dataset. The VGG19 model is a convolution neural network that is 19 layers deep, and the batch normalization is used to make a training of artificial neural networks faster and more stable. A Cypher 10 dataset contains 60,000 color images. Each image is 32 by 32 3-channel RGB image in 10 different classes that is commonly used to train machine learning and computer vision algorithms. The 10 classes are airplane, automobile, bird, cat, deer, dog, frog, horse, sheep, and truck. We divided the dataset to 3 sets. First, the training set contains 50,000 images in total. Second, the validation dataset includes 10,000 images in total. Finally, the test dataset has 10 images in total, which is generating from a validation dataset. For this part of homework, you need to train a VGG19 model with batch normalization using PyTorch. And when you submit your homework, you need to include the following parts. First, the weight file of VGG19 with batch normalization in .pth file format. The file size is approximately 500 bytes. Second, you need to include the figure of training and validation loss and accuracy in .jpg or .png image format. Another part, you need to include the code of your graphic user interface program and your code for model training. And do not include the image data in the submit file. The homework image are stored in the Q1 image folder, and this folder has 2 different subfolders. In the subfolder Q1 image, Q1_1 are 9 different images using in question 1.1 when demo using the same image. Another subfolder Q.4 they are 9 different images used in question 1.4. And these images are used for testing your program. When demoing, we will use different images for the demonstration. Here is the question 1.1. At home, here's what you need to do. First, you need to use pil.image.open. This is a function from pillow package to load the 9 images in this folder. And second, you need to apply at least 3 different types of data augmentation. Here is 3 augmentation example. Like first one is for random horizontal flip, and second is for random vertical flip, and third is a random rotation for 30 degrees. Notice this is an example, so you can use different data augmentation techniques. The figure you see on the right button is an augmented image example. You need to show when you're doing demo. And during demo, here is what you need to do. The first step is click a button. The button name will be show augmentation images, like here. And your program will load 9 images in this folder and apply the data augmentation on 9 images. And finally, show the 9 augmented images with label in a new window like this. And here are 9 augmentation image, and you need to show a label on the top of image. For question 1.2, you need to show the structure of VGG19 network with batch normalization. At home, here is what you need to do. First, you will use the torch vision package, torchvision.models.vgg19ben, and set the non-class parameter to 10 to build a VGG19 with batch normalization model. And second, you need to use torch summary, the summary function, to show the structure in the terminal, like this figure. And during demo, here is what you need to do. You need to click a button which named show model structure here in your UI program, and then run your function to show the structure in terminal, like this figure. On the right, we have a diagram of VGG19 with batch normalization structure. The first gray block represents the input, which is 32 by 32 RGB images with 3 channels. The final green block will represent the output, which is the probability distribution for 10 classes after applying softmax function. Since model is called VGG19, it contains total 19 layers, excluding the red and the purple blocks that represent the pooling layers. The remaining layers include the convolution layer, the blue block, and full connection network layer, which represent in the yellow blocks. In the middle, we have part of output generated from torch summary, the summary function, and this part is the part of this figure. The left column here shows the type of each layer. Like you can see here, the red blocks is the yellow blocks here, which contain a linear layer, which is mean fully connection network layer, and it will use with ReLU and drop out. The middle column represents the shape of feature maps. Like here, we see phone number -1, 512, 4, and 4. The -1 indicate that the actual size of batch size can be varied during your training. Like you can set a batch size to 16 or 32. And another 3 number represent the channel of this layer and height and width of the layer. And finally, the right column shows the number of parameter of each layer. The question 1.3, you need to show the structure of the VG. Sorry. The question 1.3, you need to show the training and validation accuracy and loss. At home, here is what you need to do. First, you need to use the torch vision dataset, which is CIFAR 10, to load the training and validation dataset. You can click this link for a reference tutorial. And second, you need to train and validating VGG19 with pitch normalization at least 40 epochs at home. And here is another tutorial. And you need to recall the train and validation accuracy and loss in each epoch. Notice if your validation accuracy is low, you can try to adjust a learning rate of the optimizer or change the data augmentation techniques you use. And finally, you need to save the weight file in the PTH format with highest validation accuracy. Finally, you need to use matplotlib the pyplot.plot list function to create a line chart for training and validation loss and accuracy value, and save this plot in the JPG or the PNG format. The plot will be like this example, but your value in the plot may be different. And during demo, here is what you need to do. First, we will click the button which named show accuracy and loss on your GUI, and your code should show the saved figure PG or the PNG of this training and validation loss and accuracy plus in a new window. And here is the question 1.4, the last part of the question 1. At home, here is what you need to do. First, you need to load the model which you trained at home. And then click the button load image on your GUI to display a new file selection dialog like here. And we will select one image arbitrarily. And your program should show the loaded image on the GUI. In order to make the visual clear on the UI, you should use qt.GUI.QPixelmap.scaled to scale the image from 32 by 32 to 112.8 to by 112.8 when display it. And then we will click the button which called inference to run the inference process for this image. Notice because the output should be the probability, so maybe you will need to apply the softmax function. And here is a link for another tutorial. And after you do the inference, you should show the predict class label on the GUI, which shows here. You should, if you predict the class is deer, you should show the text deer here. And finally, you should show the probability distribution of model predictions using the histogram in a new window. Like here is an example. Notice you need to add in the probability value of each bar of the plot is necessary. And during the demo, we will repeat the process about. Here is a plot example. The x-axis will be the class name. Since we use Cypher 10 dataset, you can see here we have 10 class. The first class will be airplane, and second will be automobile, like this order. And the y-axis represent the probability from 0 to 1. So you need to ensure the total probability, the summation of total probability should be 1. And since the probability of deer is highest, means your inference result will be deer. And here is a example video of question 1.1 to 1.4. Here is an example GUI. So first we click first button to show 9 augmented image on the new window. And second, we click the second button, which will show your VGG19 model structure using torch summary. And then we will click the third button to check your loss and accuracy plot. And finally, you will need to load a image and do the inference to predict which class this image is. Above is the question one. 要先问有什么问题？Any question? Okay. Sorry. Okay, this is about the second question, which is a bit different from previous assignment. It's about a generative model, specifically using a DC gain to generate handwritten digit images from MNIST datasets. Okay, this question is divided into 4 subtasks. First is MNIST to show training images and augmented training images. The second question is slow model and show model structure. The third question is show training loss. And last question is show the real images and fake images using generator. Okay, below is a simple example for the GUI. For this assignment, most of the necessary resources can be found in the provided preference here. So by following the tutorial, you should be able to implement the solution. Let's briefly introduce an objective. We aim to use a DC gain. DC gain, which stands for a deep convolution generative adversarial network model. We need to use this model to generate handwritten digits images using the MNIST datasets. So as for DC gain, it is a deep convolution. It's a convolution neural network that is made of a generator and discriminator. So what is generator? Generator means its goal is to create fake images. We need to
generate fake images that look like the training images. This is his goal. Then discriminator, its role is to differentiate between real and fake images, and which differential between real and fake images determine which ones are generated by the generator and which one come from the real data. So this is their task. The real images are from the training data set, and the fake images from the generator. Okay, so the third part is MNIST. So the MNIST dataset contains 17,000 handwritten digits, 0 to 9, with each image being 28 by 28 pixels. It's a grayscale, ranging from the 0 to 255. The dataset divided into 60,000 training data sets, training images, and 10,000 the testing images. But this task is for generative task, so all the 70,000 images will be used in training data. This figure 2 is the MNIST dataset. The fourth part is requirements. The requirements for the question are similar to the Cypher 10 task, so I won't repeat them here. It's the same. The last is homework images. Lastly, the images used in the assignment are included in the Q2 image folder, which contains the MNIST dataset of 70,000 training images. Below is a structural diagram. Okay, so the first subtask, we need to load MNIST to show training images and augmented training images. To start, we need to load the MNIST dataset to display the training images. You can see this image folder function from the torch vision datasets. This function requires 2 parameters. The first parameter is root. Roots mean the path to the dataset. So you need to put your dataset path to here. And the second parameter is transform. Transforms mean data preprocessing steps such as resizing images or augmentation. As part of a subtask, you are required to apply at least one different type of data augmentation. This allows for a visual for example, you can use the random rotation, like this 60-degree, to be your augmentation function. But the choice of augmentation is up to you. So this is not fixed. During the demo, when you click the first button, it should display the original dataset. It means not augmented training data, and alongside the augmented data. This allows for a visual comparison of how the data augmentation has modified the dataset, as shown in figure 3. So you need to bring your training data with original and with augmented training data. So we need to show the 64 images in here and 64 augmented images in here. Okay. All right, this is second subtask, loading the models and show the model structure. Because in task, you need to load the 2 models as before I talk. It's about generator and the discriminator. I will talk about generator first. First, load the structures. This function is load the generator structures to be the netg to build a generator model into GPU. The second is netg.apply. This means you need to initialize the weights. bring the initialized weights into here and to generator structures. And thus you will get, print net you will get the generator structure. The generator structure has the 40 layer showing here, zero layer to 13th layer. Each layer consists of convolutions, batch normalization, and activation functions. Oh, too small. Okay, so this is for this block, we can say it contains the 3 layers about convolution, transpose, and batch normalize and activation function. So for example, the layer 0 use transpose convolution. Commonly is used in upsampling or decoders. When the input is a 100 dimension latent vector. Yes. Okay. And the output is 512 feature maps. Following this are predefined kernel size and stride and bias. This is a default parameter. So if you want to know this, yes. Okay. Then this is for convolution parameters. Then after convolution, we into the batch normalize. Batch normalize contains this is input channels, and this is for its parameters about EPS means prevent small values that divided by 0, or momentum is about computing the moving average of mean and variance. Okay, so那可能有点太难，是他们大概知道，就是有兴趣再看就。对，因为要解释好像有点复杂。It's a default parameters. Okay, the last block, the last layer, the second layer is about ReLU. It's an activation function. Okay. So after we we do this process 4 times, 1, 2, 3, 4, and last times we get the final images. We use convolution, and that's we use a tangent edge to output our images. So the resolution becomes 60 by 60, and the final layer use tangent edge activation to output values between -1 and @1, completing the generation process. And this figure is about ReLU plot. This is about generator. The next is discriminator. And the process is similar. Replace net G with net D. Its structure is essentially the reverse of the generator. And it uses leaky ReLU. Here, it uses leaky ReLU as the activation function. And this is leaky ReLU diagram. Okay. A negative slope means the slope of activation function. So the negative input values means here. Okay. After 4 downsampling layers, 1, 2, 3, 4, it uses a sigmoid function to output here, sigmoid, to output values between 0 and 1. We can see here a value close to 1 indicates the real images, while a value close to 0 indicates fake images, aligning with the discriminator's purpose. we need to show our training loss. Once the models are set up, following the tutorials to start training, here's the link. Train the models for at least 10 epochs to ensure noticeable results. During training, save the models. If your loss is too high, you can try adjust the learning rate or change the data augmentations. These are tips for the training. Okay, so we need to save our models into with the .pth file. If you are unsure how to save or load models, you can see this link. The last use PLT, which it means a payload packet, plot our G losses and plot our D losses to create or check for generator and discriminator loss during training values. And last, we need to save this figure. So the figure shows like this. Okay. Display the training loss plot. Blue means generator loss, and orange lines means discriminator loss. And this is showing updates at every 100 iteration. The last question is generating images, real images and fake images using our generator. So we need to first we need to use the trend generator to perform inference. If you're unsure how to load model, you also can see this link. Refer to the tutorial, this tutorial. Okay, during the step, display 64 real images and 64 fake images side by side, as shown as this pictures. So you click the inference button, you need to show real images and fake images. Then fake images, which is using generator, generated by generator. Okay, so the last step is demonstrate the entire workflow through a video. So click the first button. You need to show your original training data set and augmented training data set. The second button is showing your model structure in terminal or command line with generator and discriminator structure. The third button is show your generator and discriminator loss plot. The last inference, you need to load your checkpoint to show your real images and fake images by generator. Okay, this is all the question. Any questions? 对，没有，因为他也不知道它对应的是哪一个。哦，这个 augmented 有对应的哦，有这个3有做旋转，这边是有做旋转的。
这是 latent call。
对，这是测试 latent 行。
The generative actually here, this is generative. So this is we call latent code. Latent code 就是一个码。This is 100. The vector is 100 dimension. We call latent code. So for this one, actually this is see we do the encoder and decoder. So encoder is try to encode. And because this is for discrimination, so it will be classified to either 1 or 0. However, if you encode this one, to be 100 vector, this one will be equal to this one。就是说这是因为你要想这个是一个 encoder 跟 decoder 嘛，那是 auto encoder。那上次我提到说这上份讲义 auto encoder 你就把这两个拆开。我们讲 encoder decoder 嘛，而这 generator 是不一样是刚好是两个刚好就把它拆开变成反过来。那反过来的话变成是这个变成做 discriminator， 可是我不理这个 discriminator， 实际上我这里可以产生一个100维的 latent pole， 就是里面叫我们这个100维的 vector， 我们就这里就通称为 latent pole。那这100维的 latent pole 基本上就这个，所以意思是说，我们本来 encoder decoder， 那你如果这里先不管那个0跟1，就变成100维的话，那就 encoder 就 decoder， 那意思是说你的输入等于输出，对，你的输入等于输出。那你输入等于输出以后，你把它 train 完以后呢，你把前面的 encoder 拿掉，不要理它了。那你把 decoder 就是这里 random 这100维，只要 random 什么？它出来就会一个 fake 的东西，这样子，一个假的东西。那当然，这个你如果是以手写字来讲，它就产生手写字；你如果是以人脸来讲，就人脸train，它出来就是人脸这样子。那这个只是一样，虽然我这个好像没有提到上次有大概提到，但是没有提到但是应当你们也主要是让你们了解说。这个可以用，那为什么要让你们弄这个？是因为我说目前的 stable diffusion 的东西很热门，可那个真的教不完，所以让你从座位中间让你先感觉一下，因为这个 gain 的东西最简单的就是叫 DC gain， 这篇 paper 它是最基础最简单的一个 gain 的东西，那后面这是另外一个领域，那应用非常，那我希望从这个简单的作业让你们去了解，以后你们做研究如果遇到的时候，就可以从这里稍微复习一下，也是从这里开始这样子，大家让你了解一下。OK， 那我们今天时间关系就上到这里，就下课，谢谢。助教可能要把今天的那个大家这2天就会放到 Moodle 上面嘛，就这个，那我们可以去做作业，谢谢。
先回去了。
谢谢。对啊，去有没有怎样？
没有，手失误了。